நான் ரெடியா இருக்கேன். இல்ல நான் ஓபன் பண்ணி போயிட்டேன். இல்ல நீங்க இப்போ இதுல அனுப்பிச்சல மெயில் அனுப்பிச்சீங்களா, அதுல போயிட்டேன். ஓகே.
I'm so sorry for the delay, but our session chair is just about to join the session. We're just starting in a couple of minutes.
653.
Sorry, sir?
653.
653. Oh, yeah. Okay. Sir, paper ID 653.
I tap my PPT.
Sir, I don't have your paper ID on my paper. So you are on track 8.
I'm unable to understand well. Please, not clarity.
Yes, sir.
Now tell me.
Sir, you are telling your paper ID 653.
653.
It is your paper ID.
Wait. Track 9.
Sir, I'm so sorry, but you are on the wrong track.
Meeting like please.
Sir, it's track 8.
Ninth track.
Can you send the 9th track link?
Sir, track 9.
Yeah.
Okay.
Wait, I'll talk. Just a second, sir.
Is it okay, sir? Hello.
Yes, sir.
My PPT is legible. Visualize.
Sir, you are in the wrong track. This is track number 8. And you
Okay.
Okay. Welcome, Dr. Shrikant Pan. Sorry for the delay from our side. We are just about to start the
I'm
session.
speaking to one person through chat.
Sorry.
Am I audible? Am I visible and audible?
Yes, you are audible.
I'm on track 7 actually, but I tried a lot to open that link. That was not working.
Actually, I am the coordinator for track 8, and you again have to try. I can't do anything on that.
Can you share any fresh link for track 7? Because I tried for like last half an hour. and it's not working. The track 7 link.
It is working. You have to try again.
Okay, I'll try once more.
Okay. And please leave the session. Yes, thank you. So sorry for the delay. So here we are starting the session. Good afternoon to esteemed speakers, veteran authors, and academies. Welcome to the 4th International Conference on Innovative Practices in Technology and Management, ICIPTM 2024. Dear authors, before we begin, allow me to share the objectives of this conference. The main objective of the conference is to provide the international platform for presenting and publishing the latest development in the state-of-the-art innovative practices in technology and management. With cutting-edge research outcomes related to the topics of technology and management and its interdisciplinary applications, the conference offers excellent networking opportunities for the delegates to exchange new ideas and to publish research or business links as well as to build global partnerships for potential collaboration. After the immensely successful ICIPTM 2021, 22, and 23, we are expecting this conference to be more exciting, stimulating, and educative. So, Dr. Shrikant, is there any problem with the audio? I'm repeating, Dr. Shrikant, is there any problem with the audio?
Hello. So can you hear me?
Yes.
So actually I am in track 8, but I'm not able to log in to through this Gmeet link what they have shared. So that's why I'm just mailing and I'm getting no response.
Sir, actually, please try it again. We just...
No, the Gmeet is not working, sir.
Sir,
It is
it's
asking
Zoom
for
link.
meeting ID
It's
and
not
passcode.
Gmeet link, it's Zoom link.
It's Zoom link. It's
Yes.
asking for meeting ID and passcode.
Meeting. Sir, please try it again.
Yeah, just now I tried it. So I tried with other phone also. It's asking meeting ID and passcode. Can you share that meeting ID and passcode for track 8?
I can't share in between the sessions, so please ask on the WhatsApp to any other colleague.
Excuse me, sir.
Yes, sir.
1 second. I'm here for the same issue. The MS Teams link they are provided, they're not given any meeting ID or anything like that.
Yes,
But when we go into the link, it asks for meeting ID.
Sir, right
So
now
that's
it
why
is,
we're here.
sir, right now it is working. I was facing the same problem, but right now it is working. So please try it again.
Can you share it in this group so we can try that?
Sir,
You
I'll
said
talk
it
to
is
my colleague.
working, no?
I'll talk to my colleague, but
Yeah.
right now I have to continue this session. So please.
Excuse me, Utsav, am I audible? This is Professor Srikant Pal.
Yes, sir. You're audible.
Okay, okay.
So now I would like to introduce you on with our session chairs, Dr. Shrikant Pan and Dr. Pravneet Raja, sir. So here's a brief about our session chair. Dr. Shrikant Pan is working as a professor in electronics and communication engineering in Birla Institute of Technology. Dr. Pan is currently providing services as professor and has authored and co-authored multiple peer-reviewed scientific papers and presented works at many national and international conferences. Dr. Pan's contributions have acclaimed recognition from honorable subject experts around the world. His research interests include computation, electromagnetics, terahertz sensors and imagining, RF MEMS, and many more. So welcome to this Spencer.
Thank you, Utsav.
Our next session chair will join in another couple of minutes. So before beginning this presentation, I would like to give you some brief guidelines. Dear authors, we respect your presentation, but however, we have to strictly follow the timeline of 10 minutes, out of which 7 minutes is the presentation and 3 minutes for questioning, which will mainly include the objectives of the study, research methodology, data analysis, and conclusion. And the best author will be declared in valedictory session. So here the guidelines of the session. So here I am starting the session. So now I would like to call our first presenter of the day with paper ID 581. 581 with paper
Yes, sir.
title Enhanced Deep Learning Approach for Text to Image Conversion Using Lip Movement. So can we have the presenter?
Yes. Yes, sir. Can I share my screen, sir?
Yes, sir.
Is my screen visible, sir?
Yes, sir. Your screen is visible.
Yeah. Good afternoon to all the dignitaries present over here. I am Alle Anish Kumar, here to present the paper titled Enhanced Deep Learning Approach for Text to Image Using Lip Movements, and with the paper ID 581. These are the outlines of my presentation, and starting with the main idea of the project. The project's major goal is to transform the lip reading into visually expressive 2D graphics. Without the speaker's audio, we examine the speaking person's video and translate it into the text. Using the stable diffusion and CUDA tools, we can then transform the text into dynamic and expressive pictures. For voiceless searches, this can be useful for persons who are mutic. Exam proctoring can also be done with this by just analyzing audio free videos. And coming to existing system and proposed system comparison, the existing system, we have lip reading to text conversion, which opens up many applications to discover for the research scholars. This lip reading to text conversion is done using deep learning techniques. And coming to our proposed system, in order to convert videos to text and create a more visually appealing application that can benefit humanity, we would like to use the deep learning model that is currently in use and replace it with the bidirectional LSTM model. The audio only video should be converted to pictures. And coming to the project objectives, the project's primary goal is to produce visuals from the situational conversation that lack audio. This could be a useful strategy for voiceless search and be beneficial to the people who are mutic. This might be included in the list of the numerous uses for deep learning. And coming to the project outcomes, high extraction accuracy for spoken content and text description that are contextually appropriate, and image synthesis can be visualized, which is guided by the text. And here we can see the process model, which comes to the first step as importing the dependencies. Then we are going to load the data functions by creating then next step as creating a data pipeline, and followed by the neural network and training. The final output is is predicting and building images using PyTorch. This is the architectural diagram of my project, where video is given as the input. That is nothing but without audio video. A video is then formatted to text using deep learning. Then the text is then converted to image. Coming to proposed method and algorithms, a sequential deep neural network is taken for processing voiceless videos. And for training the model, we have used a CTC loss function. And next, based on the provided silented input, the text is predicted. Once the text is generated, it is sent to be transformed into interactive visuals. We have used the tkinter GUI toolkit, PyTorch, and the transfer learning model, which is known as stable diffusion, to convert the text into the graphics. Eventually, pictures are produced. Additionally, we developed a Streamlit application to display the outcomes. And this is the result analysis. Coming to the result analysis, existing LipNet has 95.2 accuracy, which is the LSTM model, but the proposed LipNet model has the accuracy of 96.1, which is the combination of LSTM and CVAE, and the stable diffusion has the 79.2 accuracy, and the combination of the LipNet and stable diffusion model has 84% accuracy. Coming to the conclusion of my presentation, LipNet in conjunction with steady diffusion has shown to be a groundbreaking technique for lip reading to picture conversion. We achieved an outstanding 84% accuracy rate with our extensive methodology. The final step applies stable diffusion to the generated text, adding extra stability and coherence to the process, and ensuring the reliable and consistent image production. The combination of the LipNet and stable diffusion improves lip reading accuracy in difficult situations and offers a strong foundation for practical uses. Coming to the future scope, future studies and developments in the fields of lip reading and visual comprehension appear to have a bright future thanks to the integration of LipNet with the stable diffusion. With an accuracy of 84% at the moment, there is still much space for development and research in this area. Future study might concentrate on improving stability and coherence by improving stable diffusion methods, adjusting LipNet's hyperparameters and stable diffusion models, and by investigating new architectures that will have advantage of current developments in deep learning. And these are the few references of my paper, and thank you.
Thank you so much for this amazing presentation. I would request our session chairs to ask the question if any. And sir, please conclude the marking in the judgment sheet too.
Yeah, am I audible now?
Yes, sir, you're audible.
Yeah, you're just muted. So I have a couple of questions. Regarding this one, what is the background study did you do? Means actually, how far is your algorithm or process, which you are saying is a combination of LipNet and as well as stable diffusion?
Stable diffusion.
What are the existing methodologies actually already in this direction?
Yes, sir. Existing are firstly our project has two steps. Majorly, firstly the audioless video is converted into text. For that, we have a bidirectional LSTM model with 95.2 accuracy, but we have used LSTM with CVAE, which are the convolutional variational autoencoders. We have achieved the accuracy as 96.1%. Togetherly combining this both LipNet model with stable diffusion, we have 84%.
No, what is the training data? Actually, that depends on actually what is the sample you have taken, what environment you have taken your data, because the video you are taking with the audio less, and say, did you take any practical example of your data, or you have taken data from whatever is available in the internet?
No, sir. We have taken a few training samples which are used in our application, and then we have achieved the final result. We have worked with the real-time videos.
No, see, these are the algorithms or various techniques normally used for different actually collection of data, different set of data collected at different atmosphere or different time. So based on that, actually, because no method can be so accurate. So did you verify all those, or it is actually the data very clearly given about the video very clearly stated? like actually, because sometimes we may have that it's not a very obscured image, obscured video from there, how much? So those sort of any analysis has been done or anything
We
you
have
tried?
Yes, sir. We have actually we have worked with this application, and we had the uh, output which was verified by us. It is working fine, and it is working as expected also.
Can you show us that prototype, this thing development?
Yes, sir. Actually, I'm not the person to present today, but unfortunately, due to emergency situations, I am here to present it. And that model is not present in my machine, so I cannot right now.
Okay, better try next time then. Okay, I'm okay.
Okay, okay. Thank you so much, sir. Mr. Anish, you are presenting on someone's behalf.
No, sir. I am the co-author of this, but
Okay.
the actual prototype is in another machine. So
Okay.
we have decided to which the person we have decided to present. He is Kartikeya. He is the first author of our paper,
No, no, no
and
problem.
I
So
am
I'm
also.
just asking because the name was different. No problem. Thank you, sir.
Yes.
Okay, so now we are moving on to our next presenter of the day. Do we have paper ID 586?
Yes, sir.
Okay. With paper title, Exploring the Inception's V3 CNN Model for Maze Visualization and Classification via Deep Learning.
Yes, sir.
Okay, ma'am.
Is my screen visible, sir?
Yes, ma'am, your screen is visible and you're audible.
Thank you. Good morning, everyone. First of all, I would like to thank the respected conference for providing me the chance to represent my research work. So I am Muskan Agarwal from Chitkara University, here to represent the research work on the topics exploring the Inception V3 CNN model for image visualization and classification via deep learning. Paper ID 586. Now is my roadmap. Firstly, introduction, then literature, then input dataset, followed by results, conclusion, and references. On my introduction, as we know, plant diseases poses a significant risk for the global food security. Nonetheless, the prompt detection of plant diseases continues to be difficult and requires a significant amount of time. Accurate identification of plant diseases, plants' health, and the significant type of infection necessities the expertise of professionals. This study focuses on utilization of Inception V3 conventional neural network model to visually represent the categorized images of maize. The identification of maize, a widely cultivated crop, presents the challenges due to its expensive range of varieties and growth stages. By utilizing capability of Inception V3 and advanced conventional neural network architecture, our objective is to improve the perception and effectiveness of image classification. Then we have our aim and objectives. During the course of this investigation, the researchers visualized and classified in using Inception V3 CNN model. This research focuses on examination and comparing image. Furthermore, comparison of training and validation curve of loss and accuracy. The potential outcome for the future are deliberated over in the concluded section of this study. This study would be beneficial for academias who have keen interest in image visualizing. And then we have our input data set. In the figure 2, we have corn common rust disease, corn grief leaf spot disease, and corn nadran leaf blight disease. These are the images of the 3 specific disease. on the leaf, and the data set is in CSV format and was acquired from Kaggle. Input data set contain this is all right. Then we have a model using Inception V3CNN model. Inception V3CNN is a robust and esteemed architecture in the domain of deep learning. It offers strong framework for analyzing, categorizing image visualization using the Inception V3 conventional neural network architecture for visualizing and classifying image is a highly effective and combination of sophisticated design and proven technologies. Figure 3 demonstrates the efficiency of the Inception V3 model in deep learning for accurately and precisely categorizing images. It accompanies this by utilizing its complex categoristics, transfer learning ability, and adaptability for fine-tuning. Then we have exploratory data analysis. It is an essential step in deep learning model. It serves as a fundamental step to comprehend and extract insights about the dataset categorization. It facilitates the analysis of the complete dataset and provides a concise summary of its primary attributes, such as a class distribution and size distribution. Visual techniques are frequently employed to present the finding of this analysis. In the next step, known as image preprocessing, the objective is to enhance the image data by reducing unwanted distortion, resizing, and or improving important features. This process aims to make the data more suitable for model and enhance its performance. Then we have our data imbalancing is a crucial obstacle. Existence of imbalanced data sets, which certain classes exhibit a notable disparity in the number of samples compared to others. The presence of imbalance may cause the model to exhibit a bias towards the majority class during the training process, leading to suboptimal performance when it comes to minority classes. To improve the model's adaptability to accurately identify features in all classes of image, the developers can use effective strategies like data argument, weighted loss functions, and resampling techniques. It can result in more dependable and comprehensive visualization and classification result. Then we have our resampling and data imbalancing. Resampling involves modifying the dataset to balance the distribution of classes, thus improving the model's capacity to learn effectively across all classes. It improves the balance of training set, leading to improved generalization and classification accuracy for all the categories of image. It is imperative to carefully choose and evaluate resampling technique based on datasets characteristic, and as overly aggressive resampling can lead to overfitting or the loss of important information. Then we have another technique, that is class weighting. Class weighting entitles assigning distinct weights to each class during the training phase, therefore by promoting the model to allocate greater attention to underrated classes. After analyzing the Inception V3 CNN model for visualization and classification image, it is found that incorporating class weight is effective strategy to address the issue of imbalanced data by dynamically modifying the weight assigned to different classes during the training. The model effectively addressed the difficulty presented by imbalanced data, resulting in improved accuracy and reliability in the image classification outcomes. In figure 2, we have the class weights of different images that we have. Then we have our results. First of all, it's the Inception V3 model layer depictions. It carries the 7 layers in the figure 4 as the important aspect in comprehending how the Inception V3 model process and extract image visualization classification features is the presence of layers present in the analysis of offers researchers a valuable understanding of models' hierarchical learning process, enabling them to well-informed choices when studying the various examples of image. Inception V3 demonstrates its potential as a robust tool for analyzing images by utilizing deep learning to unravel their intricacies. Then we have our training the model using epochs. We have a total of 10 epochs in our image. The process of training the Inception V3 CNN model over multiple epochs is incredible and essential for achieving precise visualization and classification of image. Through a strategic navigation of epochs and careful monitoring of key metrics, researchers can enhance models' comprehensive comprehension of the data, optimize conversion, and ultimately unleash the complete potential of deep learning in the investigation of image characteristic. Then we have our training and validation accuracy curve. It is important to comprehend the pattern of training and validation accuracy curve. The theory explores the importance of monitoring and interpreting the curves in order to enhance the accuracy of the image visualization. In figure 6, our training and validation curve is given. Then we have training and validation loss curve, which is figure 7. This also helps in importance for comprehending and analysis of the curve. And then we have our conclusion over here. The Inception VE3 conventional neural network model is renowned for its efficiency in image identification task has been investigated in norm of image visualization and categorization. The objective of this research was to use the capability of Inception V3 in order to improve the perception and effectiveness of visual tasks linked to the image by using deep learning techniques. The suggested Inception V3 model accurately classifies and predicts 3 types of classes using with training accuracy of 99% and validation accuracy of 97%. The investigation of the Inception V3 CNN model for image visualization and classification has built useful insights into possible application of deep learning in agriculture. This research establish the foundation for the future efforts to provide advanced and practical solution for tackling difficulties in crop monitoring and management using advanced artificial intelligence. Here are some of our references. And thank you for giving me the opportunity to represent myself. That would be all.
Thank you so much, ma'am, for that amazing presentation. I would again request our session chair to ask a question if any.
Yeah, Muskan, actually, I have also, I'll ask you certain questions. So are you ready? Am I audible?
Yes, sir,
Yes,
you're audible.
Yeah, the thing is actually, you are telling you are doing this Inception V3 CNN model. What way this model is different from the existing other models? Because your aim is to actually identify diseases, plant diseases. So there are various other actually deep learning model. So what are those? And do you have, did you make any comparative study of your chosen model with other available model? First question is this one.
No, sir, we didn't compare it with other models.
So in
I
that
have only
respect,
used
actually,
Inception.
no, see, it has to be verified. It has to be verified when somebody is telling. So the published reports, the similar sort of actually data if you take, because it all depends on the quality of the data and the quantity of the data, training data. So ultimately, if training data is number of less, so it may give erroneous results. Yeah, so you understand, no, what I mean? So any experiment or anything trained data has to have huge amount of actually your data input. Then only you can go for it. And the model and all the, because the people when they do research, they take the data of their own choice. It's a very fine, or I would say very selected data. But in normal practical cases, when you go for actually applying your algorithm to your real life research, then you will find it's not working. So what I mean by this, actually, you need to have a good, actually, comparative study with other existing this one with a comparatively similar sort of input training data.
All right, sir. I will try to further research in it. Thank
Yeah,
you for giving me the idea.
yeah. So my suggestion would be, actually, when you do something, so you should see what is the best available and try to incorporate some novelty. If I ask you, what is your novelty? So because that's a standard question anybody will ask anywhere.
Yes.
So one should be very ready to one should be very aware or ready to actually answer that question sufficiently. Okay. Anyway, it's a
Okay,
good
sir.
try.
Thank you, sir.
Mm.
Okay, thank you so much, sir. So now we are moving on to our third presenter of the day. So do we have a presenter with paper ID 589?
Hello, I'm here.
Okay, yes, sir. So the paper title is Using Machine Learning Based Algorithms to Predict Academic Performance, a systematic literature preview.
Okay, can I start?
Yes, sir, your screen is visible.
Okay, good afternoon, ladies and gentlemen. My name is Umang, PhD student in Seki University in Malaysia, and it's with great honor to introduce and share our research outcomes, a systematic literature review presented by a team of researchers from Seki University and Siena University. The co-authors are my supervisor, Professor Dr. Gita, and with Judan, Cailing, Hongyuan, and Yirong. This is my content from the introduction, methodology, finding, discussion, and conclusions. I will introduce our work. Firstly, the introduction. The transition from offline to online learning driven by the COVID-19 outbreak has led to an urgent need to predict students' academic performance and success. So here we focus on 2 points. One is academic performance prediction. The student's academic performance prediction attempts to estimate a student's grade or performance before their enrollment in a course or examination. And secondly, the application of machine learning in education. The field of education has seen a growing interest in data mining, resulting in emergence of educational data mining. We call this one the EDM. And the machine learning modules are at the forefront of educational innovation, facilitating the personal learning, predictive analysis, and administrative efficiencies. Due to the limited in-depth research exploring the prediction of students' academic performance through the machine learning, especially after the COVID-19 pandemic, this systematic review aims to evaluate the academic performance, academic work carried out in the domain between 2020 and 2023 by trying to answer the following 3 research questions. The first one, which predictive analytic model are currently employed to assess the impact on students' academic performance? And secondly, to what degree of precision do these predictive models estimate academic performance? And thirdly, what specific student characteristics or attributes have substantial predictive power in monitoring students' academic performance? So for the methodology part, here we use 3 criteria. First one, the focus of study should be related with student performance prediction, and the year of publication should be between 2020 and 2023, and the full text is accessible for analysis. And here we introduced the Prisma flow diagram, and initially we have 83 papers, and finally after the screening we have 59 papers were selected for our research. And the database is, we use the Elsevier, Springers, Google Scholar, MDPI, and EEE. And the keywords we use are performance prediction, academic performance, and the machine learning. Here, the number of papers published, we use mostly 2022, the 18 papers, and 2021, 17 papers. Okay, for the findings and discussions, firstly, the types of papers. It's observed that there are a significant majority of papers, around 90%, focus on university level students. Because university have a more advanced infrastructure and for collecting and maintaining the students' data for further analysis compared to the non-higher education institution. And secondly, answer the research question 1. This table as a predictive analysis model used, we can conclude from these. Okay, the tree modules and the neural networks are the most used algorithms. Yeah, so to answer the RQ1, okay, we draw the conclusion. The 14 papers employ neural networks, and while 17 utilize the tree modules. And refer to the RQ2. Okay, from this table, we do the average accuracy of machine learning modules, and this one is the box plot diagram for these 5 important algorithms. For the average accuracy, we can find the ensemble learning and the SVM and performs better than others. Okay, so answer to the research question 2, we can find the ensemble learning. Okay, methods exhibit the highest average accuracy of 87.6 around percentage, followed by the SVM. Okay. Here is the advanced result. Advanced result for the different modules. For example, here we can find the tree modules were frequently employed in problems solving the regression and classification problems. The highest recorded accuracy here is percentage 99.3 by this author, Bujan. And for the neural network, the highest one is 98% by this author, Sayat. And here are some other modules, for example, the SVN, the Bayesian, and ensemble learning. Okay, let's move to the third part of the conclusion of the findings. Firstly, the word map of high frequency words. We can see the center to this image, the term demographic, gender, GPA, academic records, and grade. These factors are highly significant in the prediction of academic performance. And then we refer to the research question 3. Among these studies, 33 focused on academic characteristics, 33 on behavior characteristics, and 21 on demographic characteristics, with a total of the 46 articles incorporating at least one of these factors. So we can draw the conclusion from this image. Ultimately, the academic and behavior characteristics emerge as the most frequent utilized categories. Okay, and then let's go to this finding. It's a Sengi graph showing the relationship between the algorithms and characteristics. Firstly, we can see the neural network. Okay, the neural network demonstrated a stronger association with behavior and education characteristics. Okay, we can see this line. If it's stronger, means it has stronger, it's thicker, means a stronger relationship. For the tree model, it showed a high frequency of association with academic, behavior, and demographic attributes. And lastly, the ensemble learning is applied across a wide range of characteristics. We can see that the ensemble learning cover all these 5 characteristics. Okay, let's draw to the conclusion. Firstly, it's a systematic review, and secondly, it focuses on university level data, highlighting the neural networks and tree modules. And thirdly, the ensemble learning modules were notably effective. And fourthly, academic and behavioral characteristics as the most frequent utilized characteristic in predicting students' academic performance. And finally, the contribution is firstly, as the quality education emerged as a goal for the SDG 4, the innovation and the incorporation of these new technologies in teaching and evaluating academic performance will enhance the quality of education. Secondly, for the limitation, because the scope of this review only covers the publishing from 2020 to 2023, so further studies should cover a wider scope of the years. And lastly, for the recommendation, first point, utilize multiple data source to boost the efficiency and precision of learning analytics. Secondly, seek validation and feedback from educators and experts to integrate these algorithms more widely as instructional tools. And lastly, consider additional factors and model comparison to achieve more precise outcomes. Okay, thank you. Thank you for your listening.
Okay, thank you so much, sir, for that amazing presentation. I would again request our session chairs to ask the question.
Yeah, am I audible, Meng Yu?
Yes, sir, you are
Yeah,
audible.
yeah.
Yeah,
Hi, Prof.
yes, you have actually done some sort of survey kind of thing. After COVID, what is the actually the changes in behavioral and academic performance and all these things. But what is the bigger picture actually? Why did you do this? What is the bigger goal you aimed for?
It's because there is a widely usage of
No,
online
what I
learning.
mean by this actually, what this study will give you. What is the bigger takeaway actually from this study?
This study is focused on the post-COVID with large usage of online learning, online evaluation, and I think it's valuable to do the research on these papers to do a meta-analysis. Yeah.
Yeah, actually, the thing is, at what stage this data is taken? See, in a studies, normally a study is of certain years. So when you take this data, just at the beginning or at the end of the course, so because initially the people will be affected differently when they first hear the news, and then gradually they get settled down because online, and even how it was delivered, the learn. Now, what I mean basically, with all these studies, did you can tell or conclude something or tell to the outside world? Yes, because of this, the behavioral pattern changed this much or that much, because and whether online teaching is okay or the offline was better. So those would have been the useful study, isn't it?
So based on this research, I think we find, for example, the neural network and tree models are commonly used term. Maybe it's more effective, and example learning has more accurate accuracy of prediction. Maybe the educators and experts can use for the further as a further education tool. Yeah.
Okay, that's okay from my side.
Okay, thank you.
Okay, thank you, sir.
Okay,
So
thank
now
you.
we are moving on to our fourth presenter of the day. Presenter with paper ID 592.
Yes, sir, present. I'm present here.
Okay, so the paper title is Performance Analysis of 60 SRAM cell and 80 SRAM cell techniques using 18 nm FET technology.
Now is my screen visible, sir?
Your screen is visible.
Okay, so good afternoon, everyone. My name is Ravi Ranjan Kumar. Today, I'm here to present my paper, which is based on performance analysis of 60 SRM cell and 80 SRM cell technique using 18 nanometer FinFET technology. Paper ID 592. I'm student of Masters of Engineering from the Chitkara University. These are the outlines of my paper. The first is introduction, circuit description, methodology, conclusion, and last one references. Introduction. SRM basically stands for static random access memory. It is a type of volatile semiconductor memory which store data as long as power is supplied. The applications of SRM, the smart cities, smart buildings, smart agriculture, modern computing applications. Methodology. 60 SRM cell using FinFET, showing Fig 1, and Fig 2 shows the 80 SRM cell using FinFET. 60 SRM cell, basically it consists of 6 FinFET transistor for designing the 60 SRM cell, and 80 SRM cell is used to using 8 FinFET transistor for designing 80 SRM cell. Basically, in the SRM cell, we have performed 3 basic operations. The first is hold, read, and write operation. In the hold operation, we are holding the data inside the inverter. The M2, M3, M4, M5 are inverter basically. This is a latch. In this, we are applying the input signal at a Q terminal. So the data is passed through the Q node, and the QB is a complement of the Q. So the data is stored in this latch. So this is basic hold operation, and the read and write operation are the different. When we are perform the read operation, the WL signal is on, that is a word line that is on. So due to that reason, the access transistor, so M1 and M6 are the access transistor basically. So M1 and M6 are the on because of we are applying the high potential at a WL terminal. So whatever the data are present at BL, that is a bit line, and BLB, that is a bit line bar. So this is a basically that is basically complement of the bit line. Whatever the data are present, what are the data is present at BL. So all the data is come from BL and discharged via through M3, and that is ground. So this is a read operation, and in the write operation, we are applying the signal at BL and BLB. Both are the different potential. For example, BL, if BL is equals to 1, so BLB is equals to 0, and we are checking the write operation. So BL and BLB both are connected with precharge, and so all the data come from precharge, and the WL signal is also on in this case. So all the data are discharged via M1, M3, and then ground. So this is basic 60 SRM cell operation. And in 80 SRM cell operation, we are using one extra approach, that is read decouple technique, which is made basically M7 and M5, M7 and M8 transistors. M7 and M8 transistors. So in this case, we are not apply the term, not apply the bit signal any BL or BLB. We are seeing the data from the RBL and RD signals in this case. So this is a basically this approach used for low leakage and better static random access, better SNMs. In the write operation, we have used write operation as similar as we have done in the 60 SRM cell. So these are the graphs. Fig 3 illustrate power dissipation of 60 SRM cell and 80 power dissipation of 80 SRM cell. As we have seen, the red mark line shows the read power, which is in microwatt, and the whole power under in nanowatt, and the write power also in nanowatt. So all the power are shown in this fig A, and the 80 SRM cell shows the write power, read power, and hold power. As we have seen that the read in case of 80 SRM cell, the hold power and the write power are very less as are very high as compared 60 SRM cell. In this case, the propagation delay of 60 SRM cell and propagation delay of 80 SRM cell as shown in these two graphs. And this is a SNM, that is static noise margin of the 60 and the 80 SRM cell. That is HSNM, basically called hold static noise margin, and R called read static noise margin, and W is called write static noise margin. In case of 80 SRM cell, the HSNM and RSNM both are equal, because of we have applying in the 80 SRM cell same another technique, that is read decouple. In case of read decouple, the SNM of the read and the hold state are the similar. So okay, in this work we have attained the better outcomes in terms of write power, write delay, and read power, read delay, hold power, and SNMs as compared 80 SRM cell, as well as PDP of the, that is a power delay product of the 60 give better performance. So this is all about the SRMs, 60 and 80 SRMs. Thank you.
Okay, thank you so much, sir. Now I would again request our session chair to ask the question, if any.
Yeah, yes, again, what's your name? I just forgot. Ravi. Ravi, no?
Yes, sir.
Just tell me, what was your objective of this work, 60 and 80? What way you expected the change in actually circuital behavior?
So basically, in the 80 SRM cell, we have
You come back here. You come back to your actually the slides.
Okay,
60
sir,
and
wait.
80 circuit layout.
This one, sir.
Yeah, this one. Fine.
Okay.
Now you tell me the behavioral wise, what is the difference between 60 and 80? Why did you why
the
want
first
to go for 80?
The first of the one of the first difference in both the circuit is that we have used less number of transistor in 60 SRM cell, and more number of transistor in 80 SRM cell. And another one difference is that we have used for read approach in case of 80 SRM cell, we have used another approach, that is a read decouple technique. So in this particular technique, what we have get when we are applying this technique, so we are getting a low power, we are getting a high SNM and low power as compared the 60 SRM cell.
Amity University, Greater Noida.
Now, sir, going on.
And next my presentation.
Hello. I think others people mute it.
Sorry, sir.
Somebody else.
Sorry, sir.
So now again, yeah, Ravi, continue.
Yeah, sir, I'm already explaining you. Let me explain once again.
No. So you didn't tell me sufficiently enough. So even in your diagram on your schematic, you are writing BLB. I don't think BLB would be there. It would be directly connected to RD.
Yeah, it is connected to RD.
So, but why you are showing BLB? And what for? Why that
Okay.
additional
Sir,
additional
I'll
arm
explain
of
you. I'll explain you what is the difference in the 80. Okay, so the RBL and RD signal is a connected. RD signal is connected to the VDD, but the RBL signal is connected to the pre-charge terminal, and BL and BLB both are those terminal which are used for the write operation, and the RD and RBL, both the signals are used for the read approach.
So
in case of 80 SRM cells.
So you mean to say in case of right approach, the BLB is connected in 8?
Yes, sir. The VDD is connected with the BL and BLB with the different potential in case of the right operation of the 80 RD SRM cell.
Yeah. Yeah. No,
Yes, sir.
Then why one should go for? Why did you actually? Why one should go for 80? Because more number of transistors will give more losses,
Yes,
and
sir.
more delay.
Exactly, sir.
Functionally, what benefit I will get?
The benefit
at the expense of, what is the trade-off? At the expense of losing certain other things, features. So that is what I'm asking.
This is one of the drawback we are using in this SRM cell, number of more transistors as compared 60 SRM cell. But we are using a rate decoupled technique, which provide better SNM as compared to 60 SRM
Okay,
cell.
that I understood. Now tell me what is the novelty in your work?
Novelty. So this is 60. We have only
The novelty, because people have worked in this line. So what did you do is something extra than the
So
other existing published work.
So, sir, this is in this basically in this slide is not so much extra work. We have just simulate these two circuit only for the learning purpose.
Okay.
So
Okay. So that means
how these
just
two SRM cells are.
study purpose, you have done this.
Yeah, yes, sir.
Okay. Okay.
But now in my future, conceived so many. I mean to say, I have conceived 2 or 3 SRM cell on my way.
Okay. Okay.
Okay, thank you so much, sir. So now we are moving on to our fourth presenter of the day. So do we have presenter with the paper ID 653? I am repeating, do we have the presenter with paper ID 653?
Hello. Yeah.
Hello.
Good afternoon.
Yes, sir, you're audible.
Just a second.
Hello, can you hear me?
Yes, sir, you're audible.
My ID 653.
Yes, sir, your ID is 653 and the paper title is Advanced Seizure Prediction System for Wearable Health Management Devices using KNN Algorithms.
Yeah. Yes. I will share my presentation.
Yes, sir, you can share.
Can you see my presentation?
Yes, sir, your screen is visible.
Good afternoon to everyone. My title is Advanced Seizure Prediction System for Wearable Health Management Devices using KNN algorithm. Outline of my presentation: introduction, literature survey, proposal system, resultant discussion, conclusion, references. Introduction: seizure suffers under caregivers face significant challenges due to the
I'm so sorry for disturbing in the middle, sir, but your voice is not clear.
Now it's clear?
Yes, sir, just little slow.
Okay.
Yes, sir, fine. Go with that.
Our goal is to utilize machine learning to develop a non-interactive, proactive solution empowering seizure patients with more control over their lives while facilitating support for
He is not audible enough, actually. Nothing actually I am able to.
Not audible.
Yeah, you are not audible enough.
Now, okay, sir?
No,
Hello?
actually, I think you have to increase your voice. Be bit louder.
Okay. The unexpected onset of seizures presents an increasing the opportunity of exploring the applications of machine learning algorithms in the emerging field of wearable health technology. The key nearest neighbor algorithm being a supervised machine learning approach. So promises for seizures prediction owing to its simplicity and adaptability. Utilize KNN involves analyzing pattern in physiological data and identifying correlation with the past seizure occurrences. KNN recipes renders it suitable for scenarios where distinguish between normal and abnormal psychological data in challenging. These sensors are vital for gathering data on intact physiological signals that might indicate an impending seizure. The KNN model undergoes training on a comprehensive data sets, compromising interests of normal physiological states and pre-seizure condition. The real-time monitoring feature offers a dynamic and adaptable framework for seizures, prediction, integration, continuous analysis of incoming psychological data. Considering varying a level of technological proficiency among users of the wearable devices, the design principles prioritize use experience. Addressing ethical considerations such as data privacy, informed consent, and responsible use of predictive analytics in healthcare settings is essential for ensuring compliance. Our study endeavored to introduce an innovative seasonal prediction approach to the expanding domain of wearable health technology. Situated at the intersection of emerging technologies, this study utilized machine learning to enhance proactive healthcare solutions and the quality of life for individuals and affected by seizures. Here in literature survey, the convergence of hardware, software, and advanced predictive analytics facilitate a comprehensive approach to preventive healthcare, highlight the significance of wearable device development. Recent efforts have focused on leverage psychological signals such as electroencephalograph and electrocardiograph reading to enhance the predictive capabilities of wearable devices in seizure detection. These signals reflect brain and heart activity. Our crucial insights into the complex dynamic procedure is a seizure event. Published research underscore the efficiency of machine learning algorithm like KNN is extracting meaningful patterns from diverse data sets, laying the groundwork for precise prediction. The availability of general purpose input and output GPI ports on the Raspberry Pi simplifies the connection to psychological sensors, enabling the acquisitions of electroencephalograph and electrocardiograph data for future analysis. Furthermore, research highlights that iterative nature of model refinement, advocating continual efforts to enhance prediction accuracy through adjustment in training data sets. Collaboration among patients, healthcare professionals, and technological developers in research to ensure the ethical utilization of predictive analytics in healthcare
Arun, I
applications.
just interrupt. Actually, no, instead of going through the literature review, just let us know because of the time constraint.
Okay, sir.
Let us know
Proposal.
your objectives on what exactly you have done.
Okay.
And what is the novelty? That part you stress upon. Instead
Yeah,
of
we
going
have,
through this
there
literature
are two,
review, and I think
we
you
have,
are not left with much time. Okay?
yes, sir. Yes.
Go to the objective and straight away explain what
Proposal
did you do
methodology.
and what is the novelty. If at all it is there.
Okay, the proposed methodology, the working model of advanced seizure prediction system that is real-time psychological signal analysis to identify seizures employing a seamless integration of hardware, software, and machine learning techniques. Foundation, the system is built upon Raspberry Pi, a versatile signal board computer that manages data collection, pre-processing, and predictive analytics task efficiently. Wearable technology. Inconsistent wearable devices enable continuous monitoring of psychological signals, offering comprehensive insight into the individual's dynamic. Data processing and prototype implementation. This is the sensor unit, KNN model, cloud server, and application. Validation of a bigger dataset and real-world testing are ongoing to evaluate the system dependability and usability. This model to exploit. The software engineering component of the system plays a critical role in transforming raw psychological data into useful insights. Relevant characteristics and extracted from the electrocardiograph waveform using signal processing method. The KNN algorithm is a supervised machine learning techniques operated by assigning each data point in the feature space to the class with the k nearest neighbor, make it applicable in predicting seizure. This involves identifying similarities between current psychological signals and past events associated with the seizure. The key to the system functionality is its ability to perform continuous real-time analysis. By constantly evaluating incoming psychological data using KNN model, the system can gauge the likelihood of an impending seizure, employing a flexible and adaptive framework. It monitors the user's evolving psychological state, providing a dynamic assessment of seizure risk in real time. Ethical concerning including patient confidentiality, informed consent, and the responsible use of predictive analytics in healthcare and paramount alongside technological robust. For the acquisition, pre-processing, and real-time analysis of psychological data, the Raspberry Pi serves as the central orchestra ensuring the seamless operation. This is the result and discussion. Our study yields promising insight into seizure prediction using cutting-edge technology, specifically in KNN approach and machine learning model, demonstrate high accuracy in distinguished pattern indicate pre-seizure condition from normal metabolic signals. In each of the 1,000 samples of electroencephalograph were captured over 10-second duration and classified as pre-ictal and interictal following noise removal spectral power characteristics were extracted across different frequency models. Principal compound analysis was employed to retain 20 variables capturing over 90% of variance. The performance of the model is comprehensively assessed using the F1 score, which balance recall the precision to achieve optimal prediction accuracy. The holistic evaluation underscores the effectiveness of our approach to seizure. This is, in addition, the real-time monitoring component of the system provides response to dynamic change in the psychological condition of a person. The continuous analysis of incoming electroencephalograph and electrocardiograph reading made it possible to identify seizure-related patterns in timely manner, which significantly aided in the treatment of the patient. Here, table 1 is provide 5 patients who had seizure predicting peaks. Here, you can consider the 5 travel in the table. Data recorded. The discussion that surrounded the therapeutic implications of our results highlighted the potential influence that seizure prediction system that was established may have no treatment of epilepsy on the treatment of epilepsy and other neurological illness that are connected to it. Although the results are promising, in the inherent difficulties of seizure prediction must be carefully considered. Here we can consider support vector machine, random forest, and ensemble learning, and KNN and RF. So the following figure metric among different algorithms. If the medical field ethical considerations regarding the data privacy, informed consent, and responsible use of predictive analytics remain paramount, collaboration with the healthcare professionals and adherence to the regulatory essential to ensure the compatibility of new technologies and existing healthcare protocols. The finding and discussion underscore the potential of the advanced seizure prediction system to transform the management of epilepsy and related disorders. Hello? Hello?
Yes, sir.
Hello? The
Okay.
conclusion.
Thank you so much, sir. So I would like to again request our session chairs to ask the question, if any.
Yes.
Just tell me, what is the novelty in your work?
Hello, I'm not able to understand. Please.
What is the novelty in your work? You choose
the
this
novelty-
study. So,
Yeah.
what did you think you have done something new, which
Yeah.
others have not done?
Sir, most of the kids are suffering from seizures, sir. So
But
avoid
you
the
are not
seizure.
audible enough. Can you repeat it again?
Seizure means epilepsy.
No, the application is different. Seizure prediction.
Yeah.
So that application. Otherwise, actually, what is there any novelty other than that?
Other than that, we have to predict, sir. That is, we have to using the prediction analytics. We have to use.
No, that is a standard predictive analysis. There are these models, whatever you have mentioned, 4 models, SVM, CNN, and random forest and ensemble. These are all well known, and everybody has done. Yeah.
To collect the data from the electroencephalograph from the.
No, what you want to report then? What you want to report here?
You can reduce the seizure time, sir. You have to optimize the time.
Apart from your new application, the applications of these models, is there anything new you want to report here in this actually conference? Okay, I am fine. Yeah. What is his name? Utsav.
Yes, sir. Okay. Thank you so much, sir. So now we are moving on to our next presenter of the day. So do we have the presenter with paper ID 638?
Yes, sir. Yes, sir. I'm here.
Okay. So the paper title is Cognitive Therapy or Delusions in Patients with Paranoid Schizophrenia.
Yeah, I'll just, I'm not able to share the screen. Just. show all windows. Yeah. Okay, are you able to see my screen?
Yes, sir. Your screen is visible.
So my topic is cognitive therapy or delusions in patients with paranoid schizophrenia. So here, we just did an intervention study with 10 sample, and it was a purposely sampling technique. And the criteria for choosing this intervention study was between the age group of 25 and 55, both sexes. And
Kiran,
Yeah.
am I audible?
Yes, sir.
Can you come back to the title slide? First slide.
Yeah.
Cognitive therapy or
Cognitive
delusions in patients with paranoid schizophrenia. So you are working as a what?
I'm working as an associate professor, and
Associate
also
professor in the Department of Psychology Alliance
Yeah.
University.
Yeah.
So
And my
that's a
colleagues
medical
are
university.
my colleagues are clinical psychologists who
Okay.
were involved directly, who are also registered practitioners. They're from RCI. They have got a license, so
Okay.
they're clinical psychologists, and we all did a study together.
Okay.
So since my colleagues are traveling, so one of the person is a professor who had actually led this study. He's traveling, so he asked me to do the presentation.
Okay. Okay. Continue, please.
Yeah. So this study was having people having with refractory delusions, and who had a paranoid schizophrenia, and they were diagnosed also with the substance abuse disorders, and they were not admitted. And the study employed a pre and post intervention assessments. It was a case study designed before and after with control design. The instrument utilized in the study was an ordinal scale of preoccupation, a percentage rating of connections, a socio-demographic data sheet, and a Brown assistant of a belief scale. Additionally, it was an attempt to evaluate how well cognitive treatment worked for people with paranoid schizophrenia who had persistent delusions. The outcome showed that cognitive therapy was successful in changing beliefs, obsessions, responses to imagined paradoxes, and awareness of delusions. So the previous research also demonstrated that verbal confronting and reality testing can have an impact on delusions, which is again consistent with the current findings. So now I'll just get back quickly to the methodology. So here the need for the study was people who are having this serious mental illness. So we had provided this cognitive behavior therapy, and also people who had distinct delusions and paranoid symptoms. So the outcome of this study was the cognitive treatment was effective, and it also gave an insight and altering beliefs, preoccupations, and responses to a plausible contradiction in persistent delusions. The current study also demonstrated the efficacy of cognitive therapy as a primary treatment approach for treating patients with delusions in setting of paranoid schizophrenia in India. So the methodology include objective to determine efficacy of cognitive therapy for persistent delusions in patients with psychotic paranoid schizophrenia. And the sample was 10, as I mentioned before, and the age group comprising both 20 to 55. And the criteria was, patient diagnosed behavior with comorbid conditions of substance use disorders, and they were excluded from the study. And the research design include pre-post test, pre-post intervention evaluations. So now I'll just come back to the treatment. 10 patients were included in the study, and exclusion criteria also have been included, and tools were administered, and clinical psychologist was not included in the therapy for pre and post intervention assessment. Treatment protocol included intake interviews, baseline assessment, verbal challenge, and using Socratic method, reality testing, normalizing rational. And the statistical method was independent t-test was used. Pre-post design was employed. So this is the table one, which shows the socio-demographic data of the patients. So we also had both mixed group females and males. Those who are studying, studying PhD, graduation, secondary school, and masters. All these people were included, and the age group also. A number of sessions were 22. 22. The highest sessions was 22, and the lowest the session was 14 hours. So this was the duration that it went on. It went on for 8 months. 7 to 8 months was the time. 6 months, 7 months, and 8 months. So the treatment was given, the period of 6, 7, and 8 months. And it also shows the the patient's the conviction in the pre-assessment and post-assessment. What is the scores they have got? Then we also have the parameters. So it was in the conviction, it was again statistically significant, and in all the areas of delusions, it was the treatment was effective, and it was statistically significant at the 0.0001 level. So yeah. Then the conclusion, the purpose of the study was to evaluate effectiveness of psychotherapy for individuals with paranoid schizophrenia in addressing their persistent delusions, and significant improvements were observed in delusion of beliefs, delusion of illusion, response to counter arguments, and general presence. According to the research, this statistical research provides a compelling evidence for efficaciousness of psychotherapy in modifying beliefs and resolving prior reactions to suspicion and improving comprehension of delusions. So, however, there are a few limitations. The study modified the sample size and single case design was very small. Further trial was not controlled. Subjective measures were utilized to measure convictions and preoccupations. So, in order to evaluate the digital impact, follow-up data should be gathered, and future study should concentrate on bigger sample size with a control group. These are the references. Thank you.
Okay, thank you so much, sir, for that amazing presentation. I would again request our session chairs to ask the question.
Yeah, this is actually you have done quite a good actually detailed data, because getting some 10 patients having paranoid schizophrenia, and actually testing them or under treatment for 6 to 8 months, and that also you have recorded all those data. That's a quite good enough study actually. But the thing is, which training model actually you have used?
So CBT, cognitive behavior therapy.
So you want
Aaron
to,
Beck.
you want to report your whatever you have gathered for particularly this disease and on these many students. Then what is the finding? What information you want to share with the outside world?
So we just wanted to tell that these studies are not all the CBT is not so easily conducted on these paranoid schizophrenic with the delusion symptoms. So that is what they have a mixed the symptoms of delusions and paranoid features. So we actually wanted to tell that even they are having delusions as well as paranoid symptoms, CBT can be effective. That's what we wanted to tell.
Okay.
Because CBT is a very focused approach to certain symptoms and certain psychosis and neurosis. But here we had conditions of both delusion as well as the paranoid schizophrenia symptoms. So that is why we just wanted to check how effective CBT can work with these symptoms.
Okay, so you find this sort of actually platform would be the right one to share your findings.
Yes.
Okay, I am fine. Yeah, Utsav.
Yeah, thank you.
Okay, sir. Thank you so much, sir.
Yeah, thank you, sir.
Okay, so now we are moving on to our next presenter of the day. So do we have the presenter with paper title, paper ID 593?
Okay, sir.
So the paper title is Synergistic Models for Marigold Leaf Disease Recognition, a fusion of CNN and random forest frameworks.
Sir, my screen is visible.
Your screen is visible.
Okay, thank you. Paper title is Synergic Models for Marigold Leaf Disease Recognition, a fusion of CNN and random forest frameworks. And my paper ID is 593. And I am Ravi Ranjan Kumar, and at present I am MTech student from Chitkara University. And this is the outline of my paper. First of all, I will discuss about introduction, and then methodology, conclusion, and references. Introduction. Marigold, a versatile ornamental plant. A marigold is known for its vibrant blooms and aromatic flowers, making it popular choice for decorative purpose in gardens and landscapes. Beyond its aesthetics appeals, marigold serve various practical functions in gardening, rural and agriculture settings. Resilience against disease. Marigolds exhibit robustness against many diseases, although they are not entirely immune. Recognizing the importance of early detection and management, researchers aim to identify the forest five prevalent diseases affecting marigold leaves. Advanced disease detection model, leveraging neural network techniques such as convolution layers and random forest algorithm, a sophisticated disease detection model has been developed. This model comprises their three convolution layers designed to extract intrinsic patterns from input images, enabling accurate diagnosis of various leaf illness. Targeted disease detection. The model focus on detecting five common marigold leaf illness, including septoria leaf spot, spangles wilt, blade spot, botrytis pollution, and powdery mildew. Each disease presents unique symptoms and poses distinct challenge to marigold health, underscoring the importance of early identification and interventions. Empowering agricultures and computational method by harnessing the power of computational techniques such as CNN and random forest algorithm, researchers aim to address agriculture challenges associated with marigold leaf disease. The approach facilitated early diagnosis and interventions, supporting the prevention of marigold health and the overall sustainability of horticulture practices. And this is the methodology, advancing the methodological stages. First of all, we take the marigold leaf, which is affected by the different disease, and after that I have applied their convolution layers, and then max pooling, and after that these are the steps of random forest approaches: septoria leaf spot, fusarium's built leaf spot, uh, botrytis blight, and powdery mildew. These all are the find out by the connected of each one by using the random forest approaches. And this is the convolution matrix which has been applied to get its accuracy. And this is the result section where what perception has been found out by using the CNN and random forest model, or what effect they are found by using this technique. And this is the conclusion section. Performance matrix overview. The evolution of the multi-class classification model for citrus disease for forecasting involves several key matrices, including perceptions, recall, F1 score, support percentage, and accuracy. Accuracy of disease identification. Across all disease classes, the model demonstrates a strong accuracy, recall, and F1 scores. For instance, furism built exhibits perceptions, recall, and F1 a score reading of 97.64% and 97.97% and 97.80% respectively, with a support value indicating 1480 occurrence and a confidence level of 99%. Contribution of averaging techniques. The macro averaging, generalized average, and macro average techniques contribute to assessing the overall performance of the model. Micro average validation. The micro average aggregates measurements based on total number of positive results, false negatives, and incorrect positive across all classes. Practical implementation in agriculture. These findings underscore the model's reliability and accuracy in identifying citrus fruits illness, showing its potential for practical application in agriculture. And these are the references which I have been used in my paper. And thank you.
Okay, thank you so much for the presentation. Now I would again request our session chairs to ask the question.
Yeah, Ravi Ranjan, is this your which presentation? How many presentations you have?
Sir, actually, mainly I have 4 presentations. So.
4 presentations you have, and I'm not finding anything new in these studies. You have just reporting what you have actually just going through new as a new thing you are going through, and you are saying it is a new one, but it is not so, because all these approaches are well published, well reported long back. So only thing maybe a particular type of actually leaf or flower or seed That only is varying. Otherwise, otherwise, if I am not right, then tell me what is the novelty.
Sir, actually, in this there is not a novelty. Just we take the data set.
Reporting, the reporting. So,
Yeah,
so your all presentations are kind of reporting. But
yeah. So I have take the data
no,
and
normally these conferences are meant for to showcase any new development, any new studies. Maybe a study also new, nobody has done it, and you that done also. So that way, okay. That
yeah,
is what, because ultimately based on that only I can. Otherwise, I have my questions would be same.
yeah, yes, sir.
I am fine. What's up?
Yes, sir. Okay, thank you so much, sir. So again, Ravi Ranjan, you have another paper with paper ID 694.
Yeah,
Okay. So with paper titled Daffodil Leaf Disease Recognition Framework, a unified approach with CNN and random forest integration.
yeah, just. What is it not?
The earlier one marigold, this is jasmine leaf. Third one would be some other rubiscus, hibiscus. So some sort of those only. Are you getting what's up?
Yes, sir, I'm getting. Sir,
Okay. Let him present actually, because the
okay,
formality has to be completed.
okay, sir.
Now I will not ask any further question
Okay,
until
sir.
unless it is something new.
Sure, sir. Thank you, sir.
Yeah, just a second. Just a second. Yeah. My screen is visible.
Yes, your screen is visible.
My paper title is Towards the Perceptions Agriculture's Unified CNN and Random Forest Frameworks for Jasmine Leaf Disease Recognition. Paper ID is 595. And this is the outline of my paper.
I'm sorry for interrupting you in the middle, but your paper ID is 594.
Just a second. Actually, both are my papers. First of all, I will present this and then.
Okay, then present 595.
Okay. Yeah. And this is the introduction. Innovative disease prediction model. Just what? Yeah. Jasmine revolutionizes disease prediction by the integrating random forest and convolution neural networks, offering a sophisticated approach for forecasting illness severity across 10 distinct categories. Advanced model architecture. Jasmine architectures includes 4 convolution network layers, 3 max spling layers, and 2 fully connected layers, enabling it to extract complex agriculture features and comprehends global relationship within medical data. Enhanced prediction accuracy. The combination of CNN and random forest techniques enhance prediction accuracy and enables Jasmine to decipher intricate patterns in medical data and ensuring a reliable forecast of illness severity. Utilization of convolution layers. 3 convolution layers enabling Jasmine to detect minutes details in medical image, capturing spatial patterns that may be overlooked by traditional diagnostic methods, thus improving the accuracy of severity predictions. Resilience and reliable performance. By utilizing both CNN and random forest approaches, Jasmine demonstrate reliance and dependability in predicting illness severity across diverse instances, offering a paradigm shift in disease severity predictions and diagnosis. And this is a methodology evolutions of methodological approaches. First, we take the jasmine leaf and we find the disease which through which it will get affected. After that, we apply here CNN layer and these are the different levels in which we get its output. And this is the matrix in which it shows the how it will get worked. And this is the layers how it will get working totally the output size, numbers of filter which has been applied, filter size, just add padding, and numbers of parameters that will taken. And conclusion, comprehensive classification matrices. The classification model evaluates performance across 10 distinct classes representing different significant levels. Using matrices such as perceptions, recall, F1 score, support percentage, and accuracy. Key performance measures. Perception measures the percentage of true positive predictions among all predicted positives, while recall calculates the proportions of actual positives among all real positives. Consistent performance across classes. The model demonstrates robust performance across all significant levels, with accuracy ranging from 89.87% to 93.49%, recall from 89.65% to 92.89%, and F1 a score from 90.96% to 92.89%. Weightage average performance. The weightage average of F1 score, accuracy and recall at 91.79% indicates a strong overall performance considering the importance of each class. Based on support. Demonstrated model reliability. The support percentage averaging at 0.098 offers insight into class distribution, while the micro average accuracy closely mirrors the macro average and overall accuracy, highlighting the model reliability and perceptions in distinguishing between various significant levels. And these are the references of this paper.
Okay, thank you so much. You still have one paper left with paper ID 594, and the paper title is Daffodil Leaf Disease Recognition Framework, a unified approach with CNN and random forest integration.
Just a second, why this is not. Just a second. Just a second.
Mr. Ravi, is there any problem with sharing this?
Yeah, can I present after one?
Okay, sure. So now we are moving on to our new next presenter of the day with paper ID 599. So do we have the presenter, please?
Yes, I am here.
Okay, so the paper title is Comprehensive Analysis of Different Types of Load Frequency Controlled Algorithms of Tie-Connected Networks.
Is my screen is visible?
Yes, ma'am, your screen is visible.
Am I audible?
Yes, ma'am, you're audible.
So good afternoon, everyone. My name is Kanya Gehlot. I am a tech student from Ajay Kumar Garg Engineering College, and I am here to present my paper, which is a comprehensive analysis of different types of load frequency control algorithm for tie-line connected power system. These are outlines of my presentation, introduction. AGC, commonly referred to as load frequency control, stands for automatic generation control, is a critical component of power system operation and control for producing sufficient and high quality electric power. Automatic generation plays an important role in a large scale multi-area interconnected power system to maintain system frequency and tie-line power at nominal value. In order to maintain a frequency, a variety of control systems are used, such as model predictive control, optimal control, proportional integral controller, PID controller, etc. LFC in a single area system. Let us consider the problem of controlling the power output of the generator of closely knit electric area so as to maintain the scheduled frequency. All the generators in such an area constitute a coherent group so that all the generators speed up and slow down together, maintaining their relative power angles. Such an area is defined as a control area. To understand a load frequency control problem, we consider a single turbo generator model. This is a block diagram of single turbo generator model. From this diagram, we have mathematical model, the turbine model, governor model, and turbine model, governor model, and load model. From this is a transfer function model of this single area system. Here we use a controller I, PI, and PID controller for maintain a frequency at reasonable rate. Two-area system control, two-area control. A large power system can be broken down into a lot of tie lines connected LFC regions. According to inter-area power contracts, the current control objective is to maintain each area's frequency, which also managing the tie line power. Thus, the following goals of LFC can be stated: to preserve the frequency constant and to ensure that the frequency does not change. Every area needs to do its part, absorb changes in load. The area control error we calculated from this formula. This is the simulation model of two-area system. In this model, we use an integral controller for that to maintain the frequency constant. Also, in this model, the tie line power is 0, and the whole load change at area 1 is generated by load area 1 only. This is the same model. In this model, we use a PI controller to maintain the frequency at constant. And in this model also, the tie line power flow is 0 and response is better than the integral controller response. These are the results from these models. This result shows the frequency deviation of area 1, frequency deviation of area 2. From the results, we can see that frequency deviation of both the areas becomes 0 by using the controller, and mechanical power deviation is also shown in these graphs. Mechanical power deviation shows that if we change load at area 1 only, that load is supplied by area 1 only. Mechanical power at deviation at load area 2 is 0. Some modern LFC techniques are adaptive control strategies. In this, the behavior of the system include frequency variation, tie line power, flow, and other permittant metrics is continuously monitored by adaptive control algorithms. Robust control techniques, even in the midst of uncertainties or disturbances, robust control approaches are intended to assure stability and performance. These methods develop robust controller by taking into consideration the system uncertainties such as parameters, fluctuation, or disturbances. Third one is model predictive control, is a sophisticated control approach that makes use of mathematical model of power system to forecast the system's future behavior and choose the appropriate control measure. This is a block diagram of model predictive control. Fourth one is fuzzy logic based controller. System with inaccurate information can be modeled and controlled using fuzzy logic controller. This fuzzy logic is based on the perception that we can first the signal is converted into fuzzy language, then we apply a fuzzy logic, then defuzzication operation is done, that is converted our input signal into the output that we want. These are some intelligent load frequency control techniques. First one is artificial neural network. Neural network have ability to make precise prediction and manage action based on in-system measurement in real time. Second is genetic algorithm. Genetic algorithm is an optimization method that draws inspiration from natural selection. Genetic algorithm can be used to optimize the control parameters in LFC system. Third is particle swarm optimization, is a type of optimization algorithm. It's one of AI. It is one of artificial intelligence technique. It is a system of intelligent control that combines the method. It predicts a reason and act intelligently. Fourth is Coot optimization algorithm. Coot is one kind of bird that belongs to our adult family is a coot. Coot optimization is an optimization algorithm created by researchers based on their observation of a group of coots swimming together. Fourth is reinforcement learning. Reinforcement learning, an agent discover the best control strategy through trial and error interaction with environment. Hybrid intelligence system is a hybrid intelligence system incorporates multiple AI, artificial intelligence, or machine learning methods to take advantage of their complement strengths. Conclusion: this paper addresses low frequency control methodologies, which provides the complete overview of existing challenges with the power system network, and is also helps to design, operate, and controlling the entire tie-line connected system during on and off load conditions. The comprehensive analysis of tie-line connected multi-area power system network by using different types of controllers in MATLAB environment to obtain the optimum performance at uncertain load conditions. On analysis of performance characteristics of responsive parameters, we can easily select the suitable, efficient, and intelligent algorithm depending upon our application. These results and obtained characteristics may be further improved and enriched by the application of 2 degrees of freedom tilt integral controller and 2 degrees of freedom proportional integral controller tuned by a Coot optimization algorithm. These are the references. Thank you.
Okay, thank you so much, ma'am, for the presentation. I would again request our session chairs to ask the question.
Yeah. Actually, tell me, you have done quite a bit study on your load frequency controller. Why frequency changes with load?
Sir, a power system is at a specific parameters. If we change sudden load at area, that frequency
What
also
sort of
changes.
load you are expected to add?
Sir, we in this model we have take a base model at 1000 megawatt, and if the sudden load is increased at area 1 and area 2,
No,
then the
you have to
frequency is also
describe load in terms of actually resistive, inductive, and capacitive component. How a frequency is changed when a fundamental component is actually different or changed? When
Sir,
a frequency is changed?
Sir, if sudden load we increased at any power system area, then the
So
frequency is
that
also
changes
changed.
what? That changes what? That load is what? Sudden change in load, that changes what? In the system, that changes
That is
frequency.
such that is generator we exceeds the generator limit, sir. That is 1000
You know
megawatt.
the frequency expression. What is the frequency expression?
Yes, sir.
What is it? In terms of components, primary components, we have 3 primary components in our circuits:
Yes, sir.
resistor, inductor, capacitor. What is the relationship of frequency with those
1
components?
upon 2 pi under root LC, sir.
So L and C, that is actually omega, that is
Yes,
twice
sir.
pi f.
Yes, sir.
So either of these two has to be changed, then only frequency is changed. So which gets changed? So load is actually a reactive load, not a resistive load. Anyway,
Load is
so
inductive load.
what did you have? What did you study? In this paper? What did you study?
Sir, I studied the different controlling methods of frequency to maintain the frequency at constant level.
So that means actually frequency. So you should not change your frequency. You have to some mechanisms, so that mitigating mechanisms to control your frequency. What are those mechanisms normally? How to control frequency?
Sir, we use the controller, integral controller.
What is essentially a controller? What is a controller? What circuit it is?
So controller, we in model that is closed loop, we in feedback we connected a controller that maintains the frequency, and that steady state error that comes to 0, sir, by using the controller.
What is controller consisting of? What is a controller consisting of? What is full form of PID, PI,
So
PIDF?
proportional integral controller.
So what is this actually?
Proportional integral derivative controller, that
So what
is.
it is? What is integral derivative?
So
Who
these.
integrates, who derivate, who differentiates? Anyway, so tell me, what is your actual study? What did you want to do?
So
What is you are interested to report here? What I feel, actually, you have studied some controlling mechanism. Apart from
yes.
that, anything new are you able to actually report? See, these conferences are meant for something new,
Yes, sir.
sharing new information, either in terms of new knowledge or new product or new technique or new or advancement of actually the performance defining characteristics, parameters. Some sort of newness. It's not literature survey.
Sir, I implemented not a new technique. This implemented an existing one, but the review or new technologies that are intelligent control algorithms that are in paper, food optimization algorithm and other algorithm.
No.
That
Say,
is the new.
see.
I'm not implemented, sir,
Any
that
study
algorithm.
fundamentally, when somebody starts a study, so fundamentally it is new to him or her at the beginning. That doesn't mean it is new to the world.
Yes, sir.
So it is no way of discouragement, because something you have to study, then further you have to think what extra, what novelty, something new I can add. So if you can find something new in the already established or published domain, then that is to be reported. Okay.
Yes. Okay, sir. Thank you, sir,
Okay,
for
thank you.
suggestion.
Okay, thank you so much, sir. And ma'am, you are doing it on someone's behalf.
No, I am a presenter. That name is my correspondence author name that present in your list.
Okay, thanks for the confirmation. Thank you, ma'am. So now we are moving on to our next presenter of the day. So do we have the presenter with paper ID 612?
Yes, good evening, sir. Sir, my paper ID is 612 and the title is
The paper title is
Classifying.
Classifying Lung Cancer Disease Using
Using
Random
random.
Forest Algorithm.
Yes, sir.
Okay,
So
sir.
can I start sharing my screen?
Yes, sir. Yes, sir. Please share your screen.
Thanks for confirming, sir. So is my screen visible?
Yes, sir. Your screen is visible.
Okay. So my paper title is Classifying Lung Cancer Disease Using Random Forest Algorithm, and the main outliers of this presentation are introduction, related work, material and methods, results and discussion, and then conclusion. Coming to the first part, introduction. This is a lung cancer disease that is a significant global health concern, and this has been divided into two types: small cell carcinoma of the lung, and another is non-cell small cell carcinoma, and it could be abbreviated as SCLC or NSCLC. And as we know that cigarette, cigar, and pipe, these are the main sources of lung cancer. And the main method by which we can the which can cancer cells move throughout the blood, that is called as circulating tumor cells. And if I talk about the phases of the lung cancer prediction, the first phase is preparation phase, another is processing. In preparation phase, we have captured all the attributes of the gender, age, smoking, alcohol history, all the parameters that mostly belongs to lung cancer prediction. And the total count that I have took is 309. And the another phase is pre-processing phase, and then we have processed the preparation phase into processed phase by normalizing our data. And then another phase is training phase, and in this phase I have divided the data into two phases: training phase and validation phase. And training phase count is 70%, and whereas testing phase is 30%. And then I have evaluated the data through my model by predicting its accuracy, sensitivity, F1 score, and recall. And then I deployed this model for the real world so that we could predict the lung cancer at real time to know the disease before it's getting actually effective. And these are the related work that I have studied of the previous papers. And as in year 2019, the algorithm that has been used is CNN model, and the accuracy that has been captured is 79.6. And the main advantage of this paper is that number of images that has been took as 2000. As we know that the limitation of this paper is more less as compared to my model that providing the accuracy of 97%. And in another paper that has been published in 2020 that is based on the algorithm is PSO based CNN, that is actually particle swarm optimization, and this accuracy is 97.62 accuracy. But however, the accuracy is quite good. And if I talk about material and methodology, the main parameters that I used in phase 1, that is demographic information, where I have took the sources like gender or age details. Another is lifestyle factors to know about the smoking history and alcohol consumption of the particular patient, of which we are going to predict the lung cancer. And the another one is psychological aspects to know about the anxiety level and exposure to peer pressure. And then came to respiratory symptoms to know that if any of the patient have any respiratory symptoms like wheezing, coughing, shortness of breath, and difficulty in swallowing. And another part is pre-processing and training. In this, I have used the label encoding technique to sort the or convert the data of CSV file into the number so that the machine could understand. And I have separated this model into two parts: training set and testing set. And then I've evaluated the data through the random forest classification to classify the model through by age, smoking status, and number of health signs to get the effective accuracy. And then come to material methods. And here I have evaluated the model to know that whether the model is working right and gaining maximum accuracy. It actually has been trained by making many decision trees and all combining all the estimates to make the whole thing more accurate. And the random forest classifier basically trained on the features like I have taken two variables. The first one is X train and another one is Y train. X train is the basically independent variable, and whereas Y train is the dependent variable. If I talk about the flowchart of this model, and first I have took the number and then I pre-processed this by using label encoding and then splitted the data into training set and testing set. The suppletion has been done on the basis of 70% and 30%. 70% has been used for training set and 30% has been used for testing. And then has been detection using random forest classification. And then I have applied the random forest model. And after that, I have classified this through binary trees. And then working on the two variables like X train variable and Y train variable. These both are the dependent or independent variable. And to know about the disease, that whether any of the patient have that lung cancer or not. If I talk about the results and discussion, I have worked on this model with a data set of 201 images, and 171 has been used for training and 30 has been used for testing to achieve the more accuracy of 97%. As this has been concluded that this is a robust performance, is indicative of its potential for real world application. And here is the graphical representation of the count. And then come to results and discussion. As we know that we have predicted many models that are not able to predict the lung cancer before that have to predict. But in this model, we can predict the model more accurately by implementing this model at an initial level. Whereas another models implement the accuracy at final level, and where the situation is getting more tough at that case. And here is a graphical representation of results and discussion. The main parameters are accuracy, precision, recall, and F1 score. That they show the graphical representation of performance parameters. And coming to the conclusion, in conclusion, as we know that the accuracy is more higher as compared to other models, that is 97%, and this belongs to holistic approach. The model consideration of diverse set of parameters, including demographic, lifestyle, and health indicators, and many of the parameters has been included to achieve this prediction. Whereas in other model, the about minimum number of parameters has been implemented to predict the lung cancer. But in this, I have used many of the parameters that so that to achieve the accuracy. And this has been used for early detection. Leveraging machine learning, the model showcases the potential for early detection. That's a critical factor for improving patient outcomes and treatment efficacy. And here are the references of my paper. And then thank you.
Okay, thank you so much, sir, for that amazing presentation. I would again request our session chairs to ask the question.
Thank you, sir. Welcome.
Yeah, Vijay Madan.
Yes, good evening, sir. How are you?
So, yeah, I'm fine. So, but the thing is actually, again, the question is you have done a study. So in that study, what is the novelty?
The basically novelty in my model is that we can early predict the lung cancer before coming to the final stage. And in many
No,
other
that is not
models,
the novelty. No, that is the lung cancer before coming to the, because that's why these studies are actually meant for. Even many studies have been done to prediction of lung cancer or ultimately at what stage your lungs is. So those sort of things. In your presentation, what is the new thing which is not found anywhere in the literature? By that I mean actually you have, and then again, if you have used a model and also used data set, tell me what is the source of the data set?
the source of the data set is Kaggle.
So training data set, how did you get for your cancerous cases?
I use number of parameters like demographic details.
No. Say those parameters for any algorithm or anything, you have to add certain number of parameters. Okay, so and that number of parameters will also vary from case to case, or how accurate your algorithm is, how resilient or robust is your algorithm is. Because some people may take few parameters, some people take more parameters, and based on that, it is widely available. Your data set is widely available in the internet also. So some people take for the study, just for the study, a standard data set for oncology or cancerous in lungs. So this is available in the website someplace. So which sort of data you have used for your this thing, your study? But you cannot say that I have collected the data from the hospitals, or did you do that?
Okay. Yes, the basically novelty in this my model is that we can easily predict the lung cancer disease.
No, you didn't get my point. Okay, actually, what is it? Utsav.
Yes, sir.
Fine from my side.
Okay, thank you so much, sir. So, Mr. Ravi Ranjan, are you ready with the presentation?
Yes, sir.
Okay, then proceed. Paper title 594. Uh, paper ID
Yes, sir.
594. Paper title Daffodil Leaf Disease Recognition Framework: A Unified Approach with CNN and Random Forest Integration.
Yes, sir.
Okay.
Yeah, paper title is Daffodil Leaf Disease Recognition Framework, a unified approach with CNN and random forest integration. And my paper ID is 594. And this is the outline of my paper: introduction, methodology, conclusion, and references. Introduction: innovative disease prediction model, Jasmine evolution disease predictions, the integration, random forest, and convolution neural networks, offering a sophisticated approach to forecasting illness severity across 10 distinct categories. So just a second, I think. And just a second, sir. Please, just a second. Just a second, sir.
Okay.
नहीं अभी तक तो कोई इन्फॉर्मेशन नहीं है उसके बाद आपको
Sir, is there any problem?
No, it's okay, sir.
Okay.
Yeah. Yes. Daffodils referential disease prediction by the integration random forest and convolution neural network, offering a sophisticated approach to forecasting illness severity approach 10 distinct categories. Advanced model architecture. Daffodils architecture includes 4 convolution layers, 3 max spilling layers, and 2 fully connected layers, enabling it to extract complex agriculture features and consistent global relationship with medical data. The combination of CNN and random forest techniques enhance prediction accuracy and enables Daffodil to decipher intricate patterns in medical data, ensuring reliable forecast of illness severity. Utilizations of convolution layer. 3 convolution layers enables daffodils to detect minutes details in medical image, capturing a spatial pattern that may be overlooked by traditional diagnostics methods, thus improving the accuracy of the severity predictions. Resilience and reliable performance. By utilizing both CNN and random forest approaches, daffodils demonstrate the reliance and dependability in predicting illness severity across diverse instances, offering a paradigm shift in disease severity predictions and diagnosis. And this is a methodology. First we take the input as a daffodils leaves, and after that we apply here the CNN layers. And this is these all are the steps as leaf scotch, Norseus yellow, strips virus, one triggers, leaf blight, rust, leaf smut, vessel root, paniculum leaf blight, Astegonopsia, leaf spot, Exomophus, leaf spot, and Cucumbers mosaic virus. And these are the matrices which has been applied over the daffodil leaves. And this is a result sections. What disease, what classes predict how much its accuracy and all. And in this we can see that the leaf scotch perception is 93.53, Norseus yellow strip virus is 92.68, and these all. And this is the conclusion. Comprehensive classification matrices. The classification model evaluates performance across 10 distinct classes representing different significant levels using matrices such as perception, recall, F1 score, support percentage, and accuracy. Key performance measures. Perceptions precision measures the percentage of true positive predictions among all predicted positives, while recall calculates the proportions of actual positives among all real positives. Consistent performance across classes. The model demonstrates robust performance across all significant level with accuracy ranging from 89.87 to 93, a recall from 89 to 92, and F1 score from 90 to 92.89. Weightage average performance. The weightage average of F1 score accuracy and recall at 91.79% indicates a strong overall performance. Considering the importance of each classes based on support, demonstrated model reliability, the support percentage averaging at 0.098, offering insight into classes distribution, while the micro average accuracy closes mirrors the macro average and overall accuracy, highlighting the model's reliability and precision in distinguishing between various significant levels. And these are the references. Thank you.
Okay, thank you so much. Now I would again request our session chair whether they want to ask the question or we should move forward.
No,
as
it's fine. It's fine. It comes similar presentation and similar write up. Everything
sir.
is fine.
Okay, thank you, sir. So now we are moving forward to our next presenter of the day with paper ID 628. Do we have the presenter, please? I'm repeating, do we have the presenter with paper ID 628? Okay, so now we are moving forward with our next presenter, paper ID with 416. I'm repeating, paper ID 416.
Hello, sir. Hello, sir.
Okay.
I'm
So-
audible, sir.
Yes, sir, you're audible. With paper title, Role of Artificial Intelligence and Robotics in Shaping the Students, a Higher Educational Perspective.
Yes, sir. Yes.
Okay.
Sir, my screen is visible, sir.
No, sir, your screen is not visible right now. Yes, sir, now it is visible.
Okay, sir. So I am with paper ID 416. Role of artificial intelligence of robotics sharpening the student higher education perspective. So in introduction part, just a second, sir. Just a second, sir.
Okay, sir.
Introduction. The impact of AI and robotics on higher education is profoundly shaping the future of student learning and campus experience. This presentation explores the potential of those technologies to revolutionize education. AI in education. The artificial intelligence is enhancing the personalized learning enabling adaptive teaching method and automating administrative tasks. Its potential transform education is very fast from virtual tutorials to personal feedback. Then after that, the robotics in learning. The role of robotics in learning is that the robotic is the revolutionary STEAM education, providing hands-on learning experience, promoting problem-solving skill from coding to robotic competitions. Students are engaging in innovative learning methods. After that, the challenging and opportunities of this paper is while AI and robotics offer immense opportunities, they also present challenges such as ethical considerations, job displacements. However, the potential of equitable access and enhance the learning outcome is significant. And after that, the impact of student experience. The impact of students' experience is the integration of AI and robotics in education can enhance the student engagement, individualized learning, and career readiness. This transformation is reshaping the educational landscape for students. And after that, the future possibilities. The future possibilities is the future of education with AI and robotics is filled with possibilities for from personalized from personalized learning path to virtual reality classroom. Embarrassing this, the technology can lead to dynamic and inclusive education environment. And at last, in conclusion, the integration of AI and robotics in higher education is posed to revolutionize learning, offering immense potential for innovations and student success. Embracing these technologies can lead to transformative education experience. Thank you, sir, to giving me opportunity to present my paper. Thank
Okay,
you so much.
Thank you so much, sir. Now I would again request our session chair to ask the question. I'm repeating. I would like to ask to our session chairs whether they want to ask something. Actually, he just texted me that Just wait for some time.
Yeah, sir, sure.
Okay.
Can I stop sharing screen, sir?
Yes, sir, you can stop sharing your screen.
Okay, sir. Thank you so much.
Vaibhav?
Yes, sir, you are audible.
Yeah, tell me, actually, what is the novelty, Vaibhav?
What, sir?
What is the novelty of your work?
Sir, can you repeat, please?
See, you have done a study. So in that study, actually normally a study to be reported if it is a new study, nobody has done.
Yes, sir.
Or some research. Then
Yes,
you
sir.
have to do some research. You tell me जो आपने जो present किए हैं, whatever you have presented now,
Yes, sir.
वो new knowledge कहाँ है? Where is that new knowledge? है कुछ?
Sir, it's a AI in we use the
No, AI is see, my mom, who is not studied beyond class 10, also is telling AI, machine learning. Those days, she is 85 years old.
Yes, sir.
So she also takes the name of AI and machine learning. Okay.
Yes,
So,
sir. Yes.
that doesn't help anyway. What you have done using AI? Have you done any work?
Sir, actually, I am a co-author of this paper. The paper.
Co-author means you know what is the meaning of co-author? Author?
Yes, sir. Yes, sir.
What is the meaning of author?
Author means the person who created that paper and all
Created.
that data.
Or who has copied or written something, or dictated something, or written something. In this one, some creation is required, not writing something.
Yes, yes.
Writing is no more creation, okay? You have to work hard. Okay, okay. Yeah, I am fine with stuff.
Okay.
Yes, sir. And sir, I want to ask something, sir. He still have 5 papers, 5 more papers.
Yes, sir.
Okay.
Sir, you are not audible.
Okay, sorry. So, are you going to present?
Yes, sir.
Are you ready with the next paper? Paper
Yes,
ID
sir.
503.
Yes, sir. Yes, sir. I am ready.
So, paper ID 503, paper title Experimental Study on Analysis of Energy Harvesting and Smart Grid Powered Wireless Communicating Network.
Yes, sir. I started sharing my screen.
Yes,
hello,
sir, your screen is visible.
My paper ID is 503, Experimental Studying on Analysis of Energy Harvesting and Smart Grid Powered Wireless. In introduction part, the potential of energy harvesting and smart grid powered wireless communication network is the revolutionizing the way he harness and utilize energy. This presentation will be explore the latest advancement and the future possibilities in the existing field. The energy harvesting technology, from solar and the wind to kinetic and the thermal energy, diverse harvesting technologies are being developed to capture and convert the ambient energy into the usable electrical power. These technologies hold great promise from the sustainable energy solution. The smart grid infrastructure. The implementation of a smart grid system enable efficient distribution and management of electricity, integrating renewable energy source and enabling two-way communication between utilities and consumer. This infrastructure is crucial for a sustainable energy future. Now, the wireless communication network. The wireless communication network means the Advancement in wireless communication technologies are the facilitating the seamless connectivity and the data exchange with smart grid system. These networks enable real-time monitoring, control, and optimization of energy resources and the consumption. And after the challenges and opportunity of this paper is, while the potential of energy harvesting and the smart grid powered wireless communication network is immense, there are challenges such as the interoperability, standardization, and the cybersecurity. Addressing these challenges present opportunities for innovation and advancement in the field. After that, the application and use cases. The energy harvesting and smart grid powered wireless communication networks have a diverse application from the smart homes and building to industrial automation. The smart cities, these terminal technologies are driving the development of a sustainable and efficient energy system. And the conclusion, the exploration of energy harvesting and the smart grid powered wireless communication networks reveals the immense potential for sustainable energy solution. Continued research and innovation in this field will play a pivotal role in shaping the future of energy generation and distribution. So thank you so much, sir.
Okay, thank you so much for the presentation. I would again ask तुम लोग कहाँ आ गए? The session chair whether they want to ask something.
Hello.
Yes, sir, you are audible.
Now I'm fine. Yeah. No, it's fine because the similar kind of study, and I think the answer would be same. So I'm fine. Okay.
Okay, sir.
Okay, thank you, sir. So now we are moving on to our next presenter of the day with paper ID 504. Do we have the presenter, please?
Yes, sir. I am ready, sir.
Okay.
So next my paper ID is 504. Transformative Dynamics, unveiling the influence of artificial intelligence and cybersecurity. So the introduction part, the exploring the revolution of Bitcoin through AI, cybersecurity, and advanced technologies.
Sir, please share your screen. Your screen is not visible. You are still showing paper ID 503.
Okay, sorry, one minute, sir. Sir, is it visible?
Yes, sir, it is visible.
504.
Yes, sir.
Paper ID is 504. Transformative Dynamics, unveiling the influence of artificial intelligence and cybersecurity. In introduction part, exploring the revolution of Bitcoin through AI, cybersecurity, and advanced technologies, unveiling the potential impact on the
Is there any problem, sir? Am I audible to you, Mr. Vaibhav? So he's having some issue. Just wait for some time. He's rejoining. Till then, we are moving forward to our next presenter of the day. So do we have presenter with
hello,
paper
hello,
ID?
hello. Sir, sorry for inconvenience. My network, there are network
okay.
issue.
Okay.
Sorry, sir. Sorry,
No,
sir. Extremely sorry.
Okay. Just continue with the presentation.
Okay, sir. Sorry, sir. Sorry. Why is the introduction part, exploring the revelation of Bitcoin through the AI, cybersecurity, and advanced technologies,
Please do
unveiling the
share.
potential. Okay, sir. Sorry, sir. Oh. Is it visible, sir?
No. Yes, sir. Continue.
Okay. Then after the Bitcoin basics, the understanding the fundamentals of Bitcoin and decentralized nature, exploring the significance of the blockchain technology and its role in digital currency. After that, the AI integration, the leveraging the power of artificial intelligence to enhance the Bitcoin transactions and security, exploring the potential of AI is predicting the market trends and optimizing the transaction process. The After that, the cybersecurity advancement, the addressing the critical role of cybersecurity in safeguarding the Bitcoin transaction, exploring the advanced encryption methods and the security protocols to protect the digital assets. After that, the technology innovations, the unveiling the latest technology advancement, the shaping the future of Bitcoin from the quantum computing to IoT integration, exploring the potential impact on digital currency. Of that, the regular landscape, navigating the evolving the regulatory environment of for Bitcoin, the digital currency, analyzing the impact of regulatory changes on the adoption and the growth of Bitcoin. At the conclusion, reflecting on the transformative potential of AI, cybersecurity, and advanced technologies in revolutioning Bitcoins, embracing the future of digital finance and decentralized transition. Thank you so much, sir. And sorry for inconvenience, sir.
No, that's fine. Thank you so much for your presentation. So now I would again ask the session chair whether they want to ask something or we should move forward.
Yeah, yeah. In this Bitcoin financing using AI, did you make any study? Did you have any study?
Sir, I study about the AI, the how to implement means I collected the information about that from research papers or like that.
So you have found certain research papers wherein actually they have used the financing schemes of the Bitcoin using AI. But didn't you think while actually doing that, so I should also make a similar kind of AI model or AI this thing using some other example or
Yes,
in
sir.
some other scenario. So those sort of things are required. Okay.
Yes, sir.
Yeah. Well, that's all actually from my side because
Okay,
it is a similar kind of thing. Actually,
Yes, sir. Okay, thank you so much, sir. So now we are moving forward with our next presenter of the day with paper ID 505. So again, same, Mr. Webhook.
Yes, sir. Yes.
Okay, with paper title AI-based framework for sustainable business management using machine learning models.
Yes, sir. My screen is visible, sir. Hello.
Sir, you're still showing the Bitcoin slide.
Okay, sir. Just a second. Now it's visible, sir.
Yes, sir. Now it is visible.
Okay. The next is the paper ID is 505. AI-based frameworks for sustainable business management using the machine learning models. The introduction. Welcome to the world of AI and the machine learning is sustainable business management. In this the presentation, we will explore the potential of these technologies to revolutionize the way business operator and the make decisions. Understanding AI and ML means artificial intelligence and machine learning. In this slide, we will delve into the definition of artificial intelligence and machine learning and their relevance to sustainable business management. We will also explore the real world application and benefits, the enhancing the decision making. discover how AI and ML can empower business to make more informed and strategic decision. We will examine how predictive analytics and data-driven insights can drive sustainable practices and growth. After that, the optimizing operation. Explore the way in which the AI and ML can optimize business operations from supply chain management to energy efficiency. We will highlight the potential of automation and the process optimization. The sustainability impact. Uncover potential of AI and ML to drive positive environmental and social impact. We will showcase the example of how these technologies can enable resources efficiency and sustainable practice. After that, the challenges and consideration. The address the challenges and ethical concerns associated with integrating AI and ML in business management. We will the importance of and practice it. In conclusion, AI and ML presented unprecedented opportunities for sustainable business management. By leveraging this technology, businesses can drive innovation, efficiency, and positive impact. Embracing AI and ML is crucial for shaping a sustainable future. Thank you, sir.
Okay, thank you so much. Now I would again request our session chairs to ask the question if any.
Yeah, it is the same. Exactly the whatever I said earlier, exactly the same thing. He is actually presented these slides, thinking it is an application, so I should present. It's just that sort of. Okay.
Okay. Thank you so much, sir.
Okay.
So we are moving forward with our next presenter with paper ID 506.
Yes.
Okay. Again, Mr. Weber.
Yes, sir. Yes, sir. Sir, is it visible?
Yes, sir.
Not yet.
Yes,
And now.
Okay, sir. The paper ID is 506, Artificial Intelligence Driven Talent Management System, Exploring the Risk and the Options Sustainable Success. The introduction. Understanding the rewards and the risk powered talent management system is crucial for maximizing the success. This presentation will explore the key consideration as strategies for the effectively navigating this dynamic landscape. AI is talent management. Leveraging AI is the talent management offer the unparalleled opportunity for efficiency and the precision from the recruitment to performance. The evaluation AI driven system can revolutionize HR process, leading to better decision making and strategic talent management. After that, identifying the risk, the uncovering potential based and the ethical concern is essential where implementing AI powered talent management system. Understanding the limitation and the potential for misinterpretations for the data is critical, and mitigating risk and ensuring fair outcome. Data security. Ensuring robust data security measures is imperative where utilizing AI is talent management. Safeguarding sensitive employee information and complying with the privacy regulation are essential for the maintaining trust and integrity within the organization. After that, the maximizing the success. Strategically integrating AI into talent management can lead the enhanced recruitment outcome, improved employee engagement, and optimized performance management. Embarrassing AI potential while addressing its challenges is the key to maximizing success. After that, the ethical consideration. Prioritize ethics and the transparency in the AI-driven talent management is essential for fostering culture of the trust and fairness. Proactively addressing potential ethics DMS and ensuring accountability and crucial for sustainable success. At the conclusion, the navigating the complexity of AI-powered talent management system requires a balanced approach that addresses risk while harnessing the potential for a success by prioritizing ethics, data security, and strategic integration. Organization can unlock the future full benefits of AI in a talent management. Thank you so much, sir.
Okay, thank you. Now I would again request our session chair to ask the question, or we should move forward with the next presentation.
No, I do not have any question. Actually,
Okay.
it's the same story. Okay.
Okay. Okay, so we are moving forward to the next presentation with paper ID 507. So this is your last paper, Mr. Webber.
Yes, sir. Yes, sir. This is last. Okay. Let's start, sir. The paper ID 507.
507. With paper title Image-Based Time Series Forecasting, a Deep Convolutional Neural Network Approach.
Neutral network. Okay, sir. The image-based time series forecasting adapt convolution a neutral network. Okay. The introduction. In this presentation, we will explore the use deep learning for image-based timing series forecasting. We will delve into the challenges and opportunities in this domain and discuss the potential application and benefits that drive it. Time series forecasting. Time series forecasting involves the predicting future values based on the historical data. It's played the crucial role in a various domains such as finance, wealth, forecasting, and the resource management. Accurate and timely forecasting is essential for decision making and planning. The image-based time series data. In this application, this series data is represented as images where each pixel or region encode a data point. This unique representation poses the challenges for traditional forecasting method, making an ideal candidate for deep learning approaches. Deep learning fundamentals. Deep learning is the subset of machine learning that utilize the neural network to learn from a data. It has shown a remarkable success in various tasks, such as image recognition, natural language processing, and now time series forecasting. Understanding the fundamentals of deep learning is crucial for leveraging its power in this context. Image-based forecasting challenges. The unique characteristics of image-based time series data present challenges such as the dimensionality, spatial dependencies, and future extraction. Overcoming these challenges require innovative deep learning architectures and techniques tailored for a specific data format. Deep learning model for image-based forecasting. Several deep learning models, including conventional neural networks, CNNs, and recurrent neural network (RNN), have the adapt for image-based time series forecasting. This model offer the capability to capture temporal and spatial patterns within the data, embellishing more accurate prediction. In conclusion, the integration of deep learning with image-based time series forecasting present the promising avenue for advancing predictive analytics. And that next possibility for accurate and robust forecasting in diverse applications. Thank you, sir.
Okay, thank you so much, Mr. Webber. Now I would again request our session chairs whether they want to ask something.
It's fine. No, it's over. Okay.
Okay, thank you, sir.
Okay. Thank you so much, sir.
So, do we have the presenter with paper ID 628? I'm repeating, it's the final paper today with paper ID 628. So, you just tell me we should wait or we should wind up the session.
No, whether a call can be given to him, just pinging him once.
Just give me some time. I will ask my team. Just 2 minutes. Sir.
Yeah, sure.
So we can't call him, and my coordinators told me to bind up this session. With your permission.
Yes. Then it's fine. Then it's.
Thank you so much. So now I would like to thank our session chair, Dr. Shrikant Palsar, for their kind wisdom and kind presence, and for giving us their precious time. And also I would like to thank Amity University for providing us this wonderful platform, and everyone for joining this session, patiently cooperating, and for being such a wonderful audience. Thank you so much, all. Thank you, Mr. Shrikant, sir.
Yeah. Thank you. Because but for the candidates whosoever is actually joined, for them actually I would just say, so these are the platforms you get. So through this platform, whatever your research is, whatever your knowledge is, try to gather whatever is already there. No, you have to do something new in any form, something new, and then you can share. And these are the platforms are actually very widely connected, and you will have ample opportunity to showcase your talent or your this thing, knowledge depth, and whatever research depth. So I would thank the session coordinator Utsav and Amity University for engaging such platforms from time to time, and let us hope from these actually this sort of platforms, people enrich their knowledge and be a better human being with in terms of societal needs for the future. Okay, thank you all.
Okay, thank you so much, sir, for your wonderful guidance and all the suggestions. I hope all the researchers would go through it. Thank you, sir.